This video lesson will explain this question, but in doing so, I'm going to have to refer to certain lessons that are taught in our full-length course. So this question is a inference must be true question. We know this from the phrase follows logically. That's what that means. Assume all this stuff is true. When all these things are true, what must be true on the basis of these things? So let's read the stimulus. If the price it pays for coffee beans continues to rise, the coffee shop will have to increase its prices. So this is a classic, what we call a conditional statements. The lesson on conditional logic teaches you this. Group 1 conditionals, if is our conditional indicator, introduces sufficient conditions. So if A, then B. If the price it pays for coffee increases, then the coffee shop had an increased price. So we translate this to, we use symbols. So let's just say something like this. If the cost of beans go up, then the coffee shop will have to increase its prices. Now, one of the most common mistakes that students make is when they see this, they presume the arrow actually points this way. They presume that if the coffee shop raises prices, that means the price of beans has gone up. And that's not true. The coffee shop could raise prices for any number of reasons, but what this statement tells us is that if the cost of the beans go up, then for sure they'll increase prices. But, it doesn't have to, right? They could just decide to get greedy all of a sudden and increase their prices. Anyway, so in that case, is what we call in our grammar lessons referential phrasing, referring to the case in which, the previous case, right, in which they increase their prices, coffee shop increase. So they're basically saying if the coffee shop increases prices, then something else happens, right? So from here we can just draw the arrow out to something else, which I'm going to move this whole thing down a little bit to have more room. Then what that something else is a or. It's like saying if you go to the store, if I tell you if you go to the store, then you will buy milk or eggs. Yeah, people buy eggs in the store. You'll buy milk or eggs. That doesn't mean that I don't actually know which one you're going to get. You might get just one, you might get just the other, you might get both. Right, but that's why you have to represent this with an or. You can't have the arrow pointing to M and then have another arrow pointing to E, because that's an and. That means when you go to the store, you're going to get this and you're going to get this. So be careful not to make that mistake, and that's covered in more depth in our complex conditionals lesson. So if the prices increase, then you're going to either sell non-coffee products or sales will decrease. So I'm going to write an or because it points to the or. And here the two ideas are a coffee shop begin to sell non-coffee products or coffee sales decrease. So either they'll have to start selling non-coffee products, or just this quantity of coffee sold will go down. But we don't actually know whether it's just this that happens, or both that happens. But anyway, this represents that. So let's keep reading. There's more stuff. But selling non-coffee products will decrease the shop's overall profitability. So if this happens, if I do this, then for sure this other thing will happen, which is that overall profitability will drop. Okay, so then we can just draw an arrow over to overall profitability decreasing, right? For sure. Okay, so that's this. Moreover, the coffee shop can avoid a decrease in overall profitability only if its coffee sales do not decrease. So this sentence is confusing for most students, and it's because of the way it's because of this phrase only if. And in our conditional logic lessons, we learn that this is group 2, which always introduces necessary conditions for, let's think about it this way. You can go to law school only if you take the LSAT, right? Does that mean if you take the LSAT, you get to go to law school? No, absolutely not. Right? Plenty of people take the LSAT, but don't get to go to law school for other reasons. But if you do go to law school, then for sure you have taken the LSAT. That's for sure. So only if always introduces a necessary condition. The thing that follows only if is a necessary condition. You go to law school only if you take the LSAT. So here, the can avoid a decrease only if its coffee sales do not decrease, right? Let's think about that. Only if its coffee sales do not decrease. Which means what? Which means if its coffee sales do decrease, then what? Then it won't be able to avoid a decrease in overall profits, and its overall profits will drop, right? So I just ran what's called a contrapositive on this conditional statement. So think about it this way. If you don't take the LSAT, then what? Then for sure you're not going to law school, because every law school demands that you take the LSAT, right? So that's how you contrapose this. It's just a fancy word for saying two statements that are logically equivalent. Okay, so here you see this original idea was that only if its coffee sales do not decrease would you avoid an overall decrease in profitability. So can you this is overall decrease in profitability, avoid it, not this, right? So you just contrapose it, flip the two ideas around, negate, and then you end up with this. But hey, look, we already have this element and we already have this element. So what we can do is we can just draw an arrow over to this, right? If coffee sales decrease, then overall profitability decreases. Okay, so simplifying all of this stuff, what we actually get is just we get a very neat looking chain that goes from A over here to B, right, which then splits into a C or D, but it kind of doesn't even matter at the end of the day because both C and D go over to E, right? So it's like saying, oh, if you go to the store, then you will meet Amy. And if you meet Amy, you're going to have to buy milk or eggs. But it doesn't matter which one you get because if you buy milk, you're going to run out of money. And if you buy eggs, or if you buy eggs, you're also going to run out of money. So if you go to the store, you'll meet Amy, you'll run out of money. So if you go to the store, you'll run out of money. Right? You see how that? So that's how this whole thing works. So and that's actually what they do for that's actually what they call on for the right answer choice is they go from A all the way over to E, and they do this instead. I mean, you can also go from B over to E if you want, but that's not going to use as much of the stuff they give you in the stimulus as going from A to E does. So from A to E, here in our stimulus will be if the price of coffee beans increase, then overall profitability will for sure decrease, right? Which is what answer choice C says. If the price it pays for coffee beans continues to increase, right here, this idea, right? If that happens, then what? Then this idea. The coffee shop's overall profitability will decrease. So the other answer choices are very, very tricky, but they're all rather staple answer choices. These are answer choices that you see all the time in incorrect answer choices on inference questions or other questions that use conditional logic. So let's go through each of them in turn. A says, if the coffee shop's overall profitability decreases, then the price it pays for coffee beans will increase. So if this happens, they're saying, then it arrows back over to this thing happening. Well, that's essentially, I mean, that's exactly like saying, oh, if you take the LSAT, then you go to law school, right? Because it's just not true. I mean, what we were told is A goes to B. That doesn't mean that B goes to A, right? I mean, think about the example, if you're a cat, then you're a mammal. But if you're a mammal, that doesn't mean you're a cat. There are plenty of non-cat mammals. That's precisely what A is doing here. We like to call this the oldest trick in the book. Pretty much okay, this is an exaggeration, but I'm going to say it anyway. Pretty much every logical reasoning question with conditional logic will have a wrong answer choice that has the arrows reversed. B says, if the coffee shop's overall profit decreases, so this thing happens, if this happens, either it will have begun selling non-coffee products or its coffee sales will have decreased. So this is exactly, you see how this is exactly the same thing, right? Except it just points back over here, right? It points back over to this or, which I mean, what can I say? It's not that's not true. These two things point over to this doesn't point over to that. D says the price it pays for coffee beans cannot decrease without the coffee shop's overall profitability also decreasing. So here, the key word is without. What makes D a tricky answer choice is the use of the word without. In our conditional logic lessons, we learn that without is one of the group 3 indicators, which has a very easy to follow translation mechanism to get it from this confusing English language to very clear logic language, what the if-then statement says. But here, without having the time to teach you a whole lesson on this, but let's just think about this with an example that we're probably familiar with. Something like, I don't know, you can't go to law school without having taken the LSAT, right? You cannot go to law school without having taken the LSAT, is what we're saying. You cannot go to law school without having taken the LSAT. So how do we get this into conditional logic? Well, it's the same. You go like this. If you go to law school, then you've taken the LSAT, is what that means. Alternatively, if you don't take the LSAT or you didn't take the LSAT, then you don't get to go to law school, right? So these two are the contrapositives, which we talked about earlier. So the way you do it is you just recognize that one of these elements has a negation here, and you see this one has a negation. Coffee beans cannot decrease without the coffee shop's overall profitability decrease. So if the coffee beans decreases, if the price for coffee beans decreases, then overall profitability will also decrease. So price of beans decreases, then overall profitability decreases. But that's the translated statement for D. But you see, that's just not what it says. The stimulus told us that if you pay more for something, then your overall profitability decrease. That doesn't mean that if you pay less for something, your profitability is going to decrease. So this is not a must be true. E says either the price it pays for coffee beans will continue to increase, or the coffee shop's coffee sales will increase. See, or is actually also a conditional indicator, and it falls into group three as well. It's the translation mechanism for or is exactly the same as the translation mechanism for without. And just like what we did here, we're gonna do here. So the way that E translates, and again, I'm just gonna have to apply the translation mechanism, knowing that you won't understand this, but because we don't have time for it. But either the price it pays will continue to increase. So if the price it pays doesn't increase, right? If the price pays it doesn't increase, if it doesn't increase, which means it stays stagnant or decreases, then what? Coffee shop sales will increase, which we represented with this idea. Coffee shop sales increase. But I mean, as you can see, that's crazy. We're saying if the beans price does increase, then the coffee sales will drop. But that doesn't mean that if it doesn't increase, the coffee sales will increase. I mean, I don't know. There could be a number of things. The coffee shop could burn down, for example. Then I doubt coffee sales will increase if that happened. Even though our suppliers, our bean suppliers, are being very nice and friendly and not increasing prices on us. So just from this statement, we can't say that this must be true, right? And now you're probably wondering how we got to this statement from this, but just think about it, right? See if you can have this make sense. That's what this or means. Okay, so E is also incorrect.